So let's say we have a problem and we say limit as x gets closer to 0 of sine of 3x over sine of 2x. Now if we plug in 0 right now, that would be a sine of 0 over a sine of 0. And we know that's 0 over 0, which does not exist. It's indeterminate for us, right? We have our special indeterminate. So that means we can't do this. Gotta find another way. We do know this identity, that the limit as x approaches 0 of sine, that's a 3x over 3x, that would equal to 1, right? Our rule is if the limit as x goes to 0 of sine of x over x, where these values are the same, that always takes us to 1. Well, we're going to kind of gimmick this now. So if I give this a x over x, let's say that we write this as the limit as x approaches 0 of sine of 3x over x over sine of 2x over x. In this case, we'll give it a 3 and a 2. We'd be golden then, right? Because that would be just like a 1 over 1. So how could we get there? Well, let's write this a little differently. Let's write this as sine of 3x over 1 divided by sine of 2x over 1. We don't like dividing fractions, so let's go rewrite this as sine of 3x over 1 times 1 over sine of 2x, right? We're looking good there? Well, we want a 3x, so let's go to multiply this top by 3x over 3x. We want the one on the right by 2x over 2x. Okay. So when we simplify this, we'll have 3x on top, we have a 2x on bottom, and then we're going to have a sine of 3x over 3x, and then 2x over sine of 2x. Okay, so really, throw a limit in front of that. Oops. Let's rewrite here. Limit as x approaches 0 of 3x over 2x. And then we can write this as sine of 3x over 3x, all divided by sine of 2x over 2x. Okay. If you want to take a look at this, if we simplify this, these guys would divide out, these guys would divide out, and we still would have sine 3x over sine 2x. Okay, so what happens when we plug this into 0? These both go to 0, right? That means they're both becoming 1, and they end up 0 here. But remember, these divide out, and our answer is just 3 over 2. So it's just 3 over 2.